Okay, so we are going to get started with combinatorics. And can everyone see the screen here? Okay, so our warm-up question is, in how many ways can you put 4 different books on a shelf? So I'll give you guys a few minutes to do that. So it looks like some of you guys already know what factorials are. So that's great. A lot of you got the answer. Wait, is the answer on the screen right now? Oh, that's strange. Doesn't show that for me. Okay, that's really weird, but uh oh, is the sharing paused? Hang on a second. Can you guys see this now? Okay, great. So, let me get my pen. Okay, so how many ways are there to arrange 4 different books on a shelf? Well, for those of you who may not know how to do this question, let's go step by step. So, let's call our 4 different books our red book, our blue book, our yellow book, and our green book. So we have 4 different books, and make sure that you read the word different, because to denote that they actually are different, I drew them different colors. You don't want to accidentally assume that they're 4 of the same book, because in order to arrange 4 of the same book, there would only be one way, since all of the books are identical, and that would just be put the books in order. But when the books are colored, there are actually a lot of different ways. Right now on the screen is one. You could also have, for example, red, blue, and then you can switch the last 2, making this green and this yellow. Or, for example, you could also do red, maybe give this one yellow, make blue the 3rd one, and make green the 4th one. And so you can obviously tell there are a lot of different ways to do this. And obviously, you probably shouldn't count all 24 of them, just listing them out one by one. An easier way to do this would be to look at it and say, okay, so for the first position, how many different books can I put in the first position? Well, there's 4 books you get to choose from, which means there are 4 ways to put it in the first position. For the second position, let's say, for example, you already chose a red book. That means the red book is now eliminated, and you have 3 other books to choose for the second position. And let's say you choose green. The green is now eliminated. And how many different books do we have left for the third position? Well, for example, it could be either blue or yellow. So let's choose blue. And then finally, when you've determined the positions of all the other 3 books, there's only one book left, and that book has to go in the last position, which is the yellow one in our case. So therefore, 4 times 3 times 2 times 1 is equal to 24. So did everyone understand that? Okay, great. Okay, so let's go to the next question. And guys, please don't spam in the chat. It's great if you have a question or something, or you want to answer something that's on the board, but please don't just write something for no reason. Okay, so combinations. How many ways can a president, a vice president, and a treasurer be chosen from a group of 8 people? And how many ways can a 3-person committee be chosen from a group of 8 people? Guys, note that there are 3 people. There's a, hang on, there's a president, there's a vice president, and there's a treasurer. So you have to choose 3 out of the 8. And note that actually these 2 questions, this one and this one, have small differences because I noticed a few of you gave the same answer for both. Well, it's not really the same question because if you see here, a 3-person committee just means a committee with 3 of the same type of people. And for example, our 3-person committee here would be unordered because each of the 3 people can be swapped around and it would actually be the same committee. So choosing person A for the first spot in the committee, person B for the second spot, and person C for the third spot is the same thing as choosing person B for the first spot, person A for the second spot, and person C for the third spot. So whenever it's a committee, these 2 arrangements actually produce the same result. But however, if you had a president position and a vice president position and a treasurer position, A being the president, B being the vice president, and C being the treasurer, is actually different from B being the president, A being the vice president, and C being the treasurer. Okay, so let's go over the first question. How many ways can you choose a president, a vice president, and a treasurer? So note that that's 3 people, so we have 3 positions to fill. and we have 8 people to choose from. And also keep in mind that for this type of question, whenever they say people, you always assume that the people are different because they're not 8 identical people. That never happens in real life. So for our president position, we can choose 8 different people. And once we choose one person, there are 7 people left that we could possibly place in the vice president position. And once we choose that, there are 1 less people, or 6 people, to put in the treasurer position. So the answer here would actually be 8 times 7 times 6. And for our second question, a 3-person committee being chosen from an 8 people group means that the answer would actually be 8 choose 3 because there's a special notation for this. So let me explain what this special notation is. Basically, if you have anything of the form x choose y, then that is always going to be equal to x factorial over y factorial times x minus y factorial. So that's a formula for combinations, and you should probably remember that. A shorthand of doing this would actually be to say, okay, so we have x factorial in the numerator, which would be x times x minus 1 all the way down to y minus x minus y factorial divided by that thing. And we can actually cancel both of these terms out, which means that when we're actually solving problems with combinations, we can just write, for example, 8 times 7 times 6 divided by 3 factorial. To be clear, does everyone know what a factorial is? Okay, some people are saying no, so I'm just going to briefly go over that. So basically a factorial of, let's say, n factorial is equal to n times the number 1 less than n minus 1 times the number 1 less than that, and then all the way down to 1. So that's the definition of a factorial. So for example, 5 factorial would be 5 times 4 times 3 times 2 times 1. And 0 factorial is defined to be 1. So 3 factorial is 6, which means it would cancel out here. So our answer in the second question would be 56. And yeah, this was the formula I just mentioned. Sorry, I didn't make these slides, so you might want to take a screenshot of that or something, because that's a very important formula for combinatorics. Okay, moving on. Okay, so here's an example. Suppose we want to get from point A to point B, but we must stay on the grid, and we can only move left and right. How many ways can we do this? Okay, I'm pretty sure this is a typo here. And this is supposed to say up and right, not left and right, because if you can only move left and right, you're never gonna get to B. Well, actually, if I told you you could move in all 4 directions, then that would be infinity. Because like, for example, I could move here, then here, and then here, and then just keep moving in a circle forever. But since I told you you can only move up and right, you can't repeat your steps. So if you guys need a hint, then let me show you something here. Yeah, I know it says 8 minutes left. We can, after 8 minutes, we can log off and log back on. Um, so like for example, one possible path would be moving up 3 steps and then moving to the right 4 steps. And another way would be moving right 2 steps, moving up 2 steps, moving right 2 steps, and moving up 1 step. And another way would be moving right 3 steps, moving up 1 step, moving right 1 step, and moving up 2 steps. So I'm going to ask you guys, what do all of these paths have in common? Okay, besides the fact that they reach the same point, but something that we can mathematically use to solve this problem. Well, yes, them all using the same number of moves is close. I saw someone say they were limited by 4 and 3, so that's pretty much it, yes. So if you notice, every single step we take involves 3 ups and 4 rights. So no matter what path I draw in the figure, like for example, if I choose this random path right here, I will guarantee that it will use 3 ups and 4 rights. So basically, we've turned this question from getting A to B to arranging 3 U's and 4 R's in a sequence. Does everybody understand that? So basically, if you give me any pattern, any 7-letter word with 3 U's and 4 R's, every single word can be turned into a path on this graph. Basically, every 7-letter word is a set of instructions that you would give me for getting from A to B. So if anybody doesn't understand, you can, for example, just someone give me a 7-letter word with 3 U's and 4 R's. Okay, so someone submitted one here. U U R R R R U. So I guarantee you that with this word, I can draw a path. Okay, so Our first letter is U, which means up, so we go 1 up. Our second letter is U, so we go 1 up again. Our third letter is R, so we go 1 right. Our fourth letter is R, so we go another right. Our fifth letter is R again, we go another right. Our sixth letter is R again, so we go another right. And our seventh letter is U for up, so we go 1 step up. And we always hit point B. So do you guys understand that now? Well, it wouldn't exactly be 7 factorial because 7 factorial assumes that all the U's and all the R's are different. So like for example, if I switched these two U's, I would still get the same word. But if you used 7 factorial, it would be counted as a different word. Someone said 7 factorial divided by 16 times 8. That's closer. Well, I don't really expect you guys to get this, but the answer would actually be 7 factorial divided by, since there are 4 R's and 3 U's, 4 factorial times 3 factorial. Oh, someone got that. So this would actually be your answer. And you can calculate that if you want, but we can leave it unsimplified for now. And we have less than 1 minute left. So what I'm going to do right now is I'm going to log out quickly, and everyone can log back in so that we can start the second half of class, guys. So see you soon. Okay, hello again, everyone. So I hope you all made the journey over the internet safely. Okay, so let me share my screen. Okay, so can everyone see this? Okay. Yeah, we have to stop the annotation. Okay, let's see what we have here. Oh, I'm giving you guys all the answers. Okay. Okay, so right here we have a slightly more complicated version of the last problem. So for those of you guys who said that it was quote unquote too easy, we have a challenge now, starting here. So suppose we want to get to from point E to point G, but we must stay on the grid. Only move, okay, this shouldn't say left and right. This should say down, and right, and go through point F. How many ways can we do this? So I'll give you guys a few minutes to think about that. Okay, so a lot of you guys got the answer. That's probably because you saw it, but let's go over this anyway. So what we can do for this problem, and a common strategy to use with these types of problems, is to try to break the problem down into something that you already know. So for the last problem, you already know how to get from one point to another and count the number of ways. Here, they're telling you to get from one point, E to F, and then from F to G. This is basically what they're asking you to do. Well, they're technically telling you go from point E to point G and go through point F, but you can break the problem down to going from point E to point F, and then going from point F to point G. So this is basically the other problem times 2. So to get from point E to point F, you'll notice that we go 1, 2, 3, 4, right, and 1 down. So we have 4 rights and 1 down. So how many ways are there to arrange that in a 5-word, not 5-word, 5-letter word? Okay, I saw someone do 5 factorial over 4 factorial times 1 factorial. So let's list out a possible word here. So this is a possible word. And I know by the trick I told you before, since there's 5 letters in total, you would do 5 factorial, but then that would be overcounting because any of these R's you could switch. So there are 4 factorials to switch ways to switch around the 4 R's, and the 1D is by itself. So if you want to put 1 factorial there, you can. So that would actually give 5 factorial over 4 factorial, which is 5. So to get from E to F, you know that there are 5 ways to do so. And now we have to go from F to G. So to go from F to G, we have 1 right, and then 1, 2, 3 downs. So how many ways are there to arrange 1 right and 3 downs in a 4-letter word? Okay, good, you guys got this. So an example would be dr dd. And the way you would calculate this is 4 factorial divided by 3 factorial to account for the overcounting with the 3 d's. And that would give you 4. So then, can you guys put this together? And since you know that from E to F is 5 ways and from F to G is 4 ways, how many ways are there in total? Okay, you don't add them, so please stop spamming 9. You wouldn't add them, you would actually multiply them. And so 4 times 5 is equal to 20. So does anyone have any questions? Okay. Okay, so we're gonna ignore that number right there. More examples. There are 30 men and 40 women. They wish to form a 7-person committee with 3 men and 4 women. In how many ways can they form this committee? So I'll give you guys a few minutes to think about that. Okay, so note that it says 7-person committee. So whenever you see the word committee, then all the positions are going to be the same. So for example, if you had 7 entries, then a person being in this entry in the committee, being the first person, and the person being the 4th person in the committee would actually be the same. Since in a committee, there's no placement of people. Okay, so if you're stuck here, then keep in mind that you can consider the men and the women separately. So like you can reserve 3 spots in the committee for men and 4 spots in the committee for women. And find out how to place the 30 men and the 40 women in those 2 categories separately. Because you're never going to place a man in a woman's spot and a woman in a man's spot. Okay, so let's get started here. So let's consider the men first. So we know that definitively 3 men are on the committee, but we have 30 men to choose from. So using combinations that we learned today, there are 30, choose 3 ways to choose men for the committee. And you could calculate this out, and this would be 30 times 29 times 28 divided by 3 factorial, but we're not going to do that because I don't want to work with big numbers. And similarly, for women, we have 4 positions, but we have 40 people to choose from. So we would do 40 choose 4 for the number of ways to put 4 women in the committee. And this would be 40 times 39 times 38 times 37 divided by 4 factorial. So can anyone here finish the problem and tell me what we should do with those two numbers that we got? 30 choose 3 and 40 choose 4. So for those of you saying add, let me just give you guys a quick reminder on the difference between adding and multiplying in combinations. So you multiply whenever you have two separate categories that don't affect each other. So for example, this problem would actually be multiplying because the 30 choose 3 and the 40 choose 4 have no impact on each other. So the 3 men that I choose here has nothing to do with the 4 women I choose here. And therefore, every single way to arrange 3 men has an equal number of ways to arrange 4 women. And so therefore, you would actually multiply these two numbers. And yeah, this would be our answer. So yeah, it's kind of big. I obviously don't expect you guys to do that by hand. If you can do that by hand, then you're awesome, guys. But you probably use the calculator, so. And that appears to be our class today. Unless I have really bad eyesight. Thank you guys for coming. And I'll see you next time where we'll probably do combinations again. So have a good night, guys. Yes, there are more classes. So we're having a class every Wednesday at exactly this time until June 24th. And once that date comes, you can check our website for updates. Okay, so I'll see you guys. I'll close this form out. Goodbye.